We're going to keep talking about series today, so we're going to learn a new notation called sigma notation. Now, the reason it's called sigma notation is because it involves the Greek letter sigma. So that's this letter right here. This is a letter from the Greek alphabet. It's the letter that's called sigma. It looks kind of like R capital E, except instead of having a perfectly straight line on the left-hand side, it has that angled one. That bent side there. But that's the Greek letter sigma, and whenever you see that letter, what it means is it's a series, just like we did in the last day of notes. So let's talk about how we are going to take this sigma notation, read it, and understand what the series actually is. Because remember, we learned last section that a series is a list of numbers that you add together. Well, there's no list of numbers here. But the sigma notation, if you know how to read it, tells you how to make the list of numbers. So this is how you're going to make your series. Start off over there on the right-hand side. Whatever you see to the right of the sigma, the letter sigma, that's the formula that you're going to use to make terms. So we're going to plug numbers into that formula to make our terms, and the numbers above and below sigma tell you which numbers to plug in. So you start with the number underneath it. If it says n equals 1, I plug in 1 first. If it says n equals 5, I plug in 5 first. Now once you found that first number, you count from there. And you keep counting, you keep plugging numbers in until you get to the one on top. So basically the number below and above sigma tells you what you're starting and stopping with when you're plugging in numbers to make terms. So let's put that into words. For this example here, this is the same one. I would say I'm going to use that 2n, meaning 2 times n. I'm going to say, just like we did when we did sequences, let's call it an, because that's our formula for creating terms. So I'm going to use an equals whatever I see over here. In this case, it's 2n. And I'm going to use that to plug numbers into and make my terms. So then when I start plugging in numbers, I look down here and I say, okay, there's a 1 there. So I'm going to plug in 1 first. So I plug in 1 and I get an answer. That's the first term. Then I keep going from there. After 1 comes 2, and then 3, and then 4, and then ... And you keep going as long as you need to, but you stop when you plug this number in. That's the last number you plug in. So let's do this. Let's take this exact same problem and just turn it into an example. Let's evaluate this series right here. So I'm going to do that. I'm going to start plugging in numbers. Let's plug in 1 first. So I'm going to use this. I'm going to use an equals 2n. I'm using this formula right here. It's a very simple formula for the first example. And I'm going to plug in the first number, 1. So basically, I'm going to find a1, the first term. Well, if I plug in 1 for n, I get 2 times 1, which is just 2. So let's make this our sequence down here, 2 plus. And then I'm going to plug in 2. So if I plug in 2 for n, I have 2 times 2, which is 4. So my next term is 4. And then I plug in 3 for n. 2 times 3 would be 6. Oops, it's in blue, but that's okay. All right. And then the next step would be to plug in 4 for n, although once you find the pattern, you don't have to keep plugging in numbers. I'm going to get an 8 here. And then once you see the pattern, you say, okay, well, if I plug in 5, I'm going to get 10. And if I plug in 6, I'm going to get 12. And that's where I stop. Because right here, this was A6. This is when I plugged in 6. So that's how I know when to stop. So the sigma notation, with a little bit of work, helped me turn it into a series. Now we're still not done with the question, because remember, when you're doing a series, you do want to actually add them all up. So once we add those 6 numbers together, that'll be our final answer. So let's do that. 2 plus 4 is 6, plus 6 is 12, plus 8 is 20, plus 10 is 30, and plus 12 is 42. So my answer is going to be 42. So that sigma notation, and we would say sigma, or the sum from 1 to 6 of 2n equals 42. But you guys get the idea. Sigma notation, it's a new notation. It's a more compact notation of writing out series, but your goal is to be able to read it and turn this into this so that you can very easily finish the question by just adding them up. All right, I want to try one more with you guys. Here's another sigma question. So you see the letter sigma there in the middle. This time the formula is a little bit more complex. Instead of just a nice simple 2n, we have 3n minus 15. But basically, this is going to be my formula that I'm plugging numbers in for. Now, I'm not going to plug 1 in first. So that's a common mistake, is a lot of people just automatically plug in 1 and then 2 and then 3. Remember, this tells you what number to plug in first. So the first thing I'm going to plug in is 3. I want to find a 3 first. And I'm plugging it in for n. I'm putting it right here. So I would have 3 times 3 minus 15. 3 times 3 is 9. And 9 minus 15 is negative 6. So my first term is going to be negative 6. Okay, now remember, once you have that starting number 3, you're going to count from there. So basically, the next one I plug in is 4, and then 5, and then 6, and then 7, which you see up there, and that's how you know when to stop. So I'm going to plug in 4 next. That would be 3 times 4 minus 15. 3 times 4 is 12, and 12 minus 15 is negative 3. So my next one is negative 3. All right, we did 3 and then 4. Let's do 5 next. 3 times 5 minus 15. 3 times 5 is 15, and 15 minus 15 is 0. So I'm going to have plus 0 for that term. The next one is A6. We plugged in 3, then 4, then 5. Let's plug in 6. That would be 3 times 6 minus 15. 3 times 6 is 18. And 18 minus 15 is 3. Now since that was a positive 3, I'm going to put plus 3. The next number I plug in is 7, and this is where I stop, because remember I got a 7 up here. 3 times 7 minus 15. 3 times 7 is 21. 21 minus 15 is 6, so I'm going to have a plus 6 on the end. So basically what I did, I started by plugging in 3 for x. I counted through all my numbers, 4, 5, 6, 7. Then I stopped when I got to 7. That's how sigma notation works. You're plugging in every number starting with the bottom one, counting by ones until you get to the top number. Now the actual answer to this question is 0, because you have, if you look at it, you have a negative 6 and a positive 6. Those cancel each other out. You have a negative 3 and a positive 3. Those cancel each other out. You have the 0 in the middle. So when you add this all up, my actual answer to this question is 0. And then just as one more little side note here, as you start to have a little bit of practice, if you just like when we did sequences, if you recognize the pattern, maybe you don't need to do all the work. Like maybe you saw the first number was negative 6, the second number was negative 3, the third number is 0, and you go, well, I'm just adding 3 each time. So the next number would be positive 3, and then positive 6. And if I had to do A8 without doing the work, the next one would be plus 9, and then plus 12, and plus 15, because these follow the same rules as sequences. So once you find the pattern, you may not need to do all of this work. You may have only done like these 3 here, and found the first 3 terms, and then you figured out the pattern. You're like, I don't need to plug in 6 and 7. I know the next 2 are going to be 3 and 6. And that's fine too. Once you find the pattern, you can finish it out. But make sure you are stopping at the right one. That's the tricky part. You got to stop on when you're plugging in the number 7, basically.